Hi, Benazir. It's an absolute pleasure to welcome you and have you as a guest in this Thought Leadership webcast. So, first, let me introduce you. So Benazir works as a AI ML specialist at Google, helping Google's cloud's largest customers transform their businesses by solving problems that they face with creating scalable end-to-end machine learning solutions. Prior to Google, Benazir worked in retail and precision agriculture industries, leading multiple design and implementation of data science solutions. Benazir is a hands-on data scientist with diverse experience in research and in delivering scalable and productionable machine learning solutions. She is an ambassador with the Women in Data Science organization and volunteers her time to mentor young professionals and seniors in school. Benazir earned a PhD degree in computer engineering from Iowa State University in May 2013. She is originally from India and currently resides in the San Francisco Bay Area. So you can understand, like, it's absolutely a great uh, chance for us to ask Benazir a lot of questions regarding to MLOps, machine learning, anything from Google. So let's utilize this chance and learn from our experiences. Welcome, Benazir, once again.
Thank you. Thank you, Sharmishta. Thank you so much for the great introduction. It's a privilege to be hosted on this webcast by you. Um, I have to tell you, I'm a fan. I read your blogs and your of your work in machine learning. So it's an honor to be here. Thank you.
Thank you. So let's have a free discussion. I will ask you a set of questions, but beyond that, feel free to share whatever experiences you have. So let's get started with. We had your interaction. Learn more about how did you had your journey in data science. I'm sure 2013 when you did your PhD, right? There was not so much buzz around data science. So how did you move to that role?
Yeah, that's right. So I remember like when I was doing my PhD, there was a lot of we used to hear a lot of things about big data. So there was, companies were of course acquiring a lot of data, but then there was a lot of uncertainty, or at least from like as a student, I couldn't find much resources about what is big data, what is cloud computing, what do you do with it, what are the application, the end use cases. And of course, as time passed, we found out more about these. But yes, my PhD was not in data science. It was actually in embedded computer engineering. And my PhD thesis mainly focused on resource management in wireless networks. So after my PhD, when I graduated in 2013, I joined John Deere. It's a precision agriculture company. And in my like 5 years at John Deere, especially towards the end, like towards 2016, 2017, John Deere was moving to AWS, and they were thinking a lot about, okay, they have all this machine data, agronomic data. How can they use it? So that's where I started doing a lot of like two things. One was data modeling with respect to, okay, what machine data should we collect, curate, and clean so that it could be used later for to make some to generate models or to generate some insights.
Mm-hmm.
Then I started learning more about data science. And of course, I started with the legendary course by Andrew Ng, which is the machine learning course, which I recommend to everyone. And then I started just playing around with more modeling techniques by myself. And the first job that I got, so this is when I was in Bangalore, I started a job in retail. And this company called AI Enterprise, we were working with retail lifestyle stores in US. And
Mm-hmm.
that's when I started working on recommendation systems and personalization algorithms. So I learned more about those type of use cases in retail.
Mm-hmm.
Uh, and then in my current job, I do so. In my previous job, I was doing a lot of just like, mostly focused on modeling. Um, but in my current job, I do a lot of like not just modeling, but in helping companies like build end-to-end ML solutions. there's a lot of ML ops that comes into picture. So, not just modeling, but what happens after you, like, how can you deploy a model in production? What are the things that you need to monitor? So, a lot of end to end view is what I'm getting in my current role.
Mm-hmm.
So,
So,
mhm,
yeah,
that's how I got into the field of data science. And of course, it's a continuously evolving field. So,
yeah,
I just, like everyone else, I try to continuously learn and keep myself updated.
yeah. So, is it initially may not be the all the time you were doing data science, but gradually it was like all part of it was data science, right? If I
Yes.
try to
Yes.
understand, initially it was a mix of it, right?
Yes, that's correct. Yeah.
Yeah, that's great. So, around our topic is like MLOps, ML pipelines. So, can you help us to understand how important they are in terms of not only building the machine learning models, but also having a service, useful service when we deploy in terms of use cases? How useful are they?
Definitely. I just want to proceed with a note that all the views that I expressed today are solely mine and not that of Google. This is a great question. Like, how are ML pipelines and feature store helping us? So mainly, like, data science is an experimental field. There is a lot of uh, coding that you have to do, like the lot of modeling that you have to do. And of course, there's a lot of, like, changes in data that can happen. So you do a, like, it's not just one model that you create and you're happy with it. You create multiple models. For all those models, there's a lot of hyperparameter tuning, and different types of train test split that you do hyperparameter tuning. You identify what metrics you want to optimize your model on. So there's a lot of experimentation that goes on. And as you know, in companies of bigger sizes, we see that different types of this job, like in creating one machine learning model, all the different jobs of cleaning up the data, doing the modeling, doing evaluation, is done by different sorts of people.
Mm-hmm.
So or different teams. So there are all these complexities when they add up. Now, if you are an organization that's doing, just, you're a small shop, you're just doing one model, you know and you don't train it in a long, like, you train it once in 6 months. Well,
Right.
okay, you can still do things manually. But if now that we've seen that, companies frequently use, like, machine learning models are trained like once every day, not just one, thousands of models are trained. So how do you make sure that this whole experimentation process is repeatable and is reliable and less error prone and is very automated? So pipelines, like machine learning pipelines, lets you do exactly that. They let you orchestrate, because there are different steps in this pipeline. So they let you orchestrate and automate all these different steps in the ML workflow.
Mm-hmm.
And so that, of course, there are multiple people involved, multiple tasks involved, and they could be done at different frequency. Like with machine learning pipeline, the great thing is, you have this repeatable module. You could trigger it, like you could trigger it on demand, or like if there is a schedule, you need to train models daily, you could do that. Or things like when there is new data, like you identify that there's new data in your whatever storage, you could trigger this pipeline. Or of course, when you trained a model, it's in production, but model performance is slowly, like, you're monitoring models, but model performance is slowly degrading. And that's when say that, okay, it's gone below a threshold, it's time to retrain a new model. So you have this artifact, which is the pipeline, you can trigger it again with new data, and you
Mm-hmm.
get the same set of steps followed reliably and repeatably, and you get a new model. So in that sense, I feel that machine learning pipelines, which is of course provided by so many different providers, is very important. And Same with feature store. Like what happens is, like, I think a feature store as when like a few years down the line, when we had data in all the different sort of databases, and a data analyst would have to uh, gather data from different places and do some analytics on it. I mean, do some processing on it, and then derive some analytics. Well, now you have data warehouses. What they are saying is, s- process all your data, save it here in this format. When an analyst needs it for insights, here you go, you grab it from this warehouse. Same with feature store. Like, feature store is this interface between models and data. So what you're saying is, somebody has created, like in your company, somebody has created a feature that is valuable. You can put it in the feature store, other people can reuse it. So in that sense, even feature store provides this repeatable way of, like, you can of course organize and store features, and most importantly, you can serve those features like from the feature store.
Okay, so you
uh,
mean to say there will be APIs to serve the features, or
yes.
internal or external? Means will it be external facing or internal facing for my models?
So like feature store, yeah, they could, like, by
By
uh,
I can consume through my models can consume those
yes,
features somehow.
yes, your
Somehow,
models can
yeah.
consume both. When you are training, so when you're training, you need all this historical
Features.
data. You can get that through APIs, and also when you're serving, then as part of feature store, one component that you design, I mean, the feature store, like if you're using off the shelf feature store, then for online serving they have a like a OLTP database, so that your features could be served with low latency in real time. And yeah, there are APIs so that you could get um, uh, that feature. So you know like feature store, like this problem of training serving skew,
Mm-hmm.
um, which is saying that when people train a model, you have all the time, you pre-process your features very nicely, and you use that to train your model, great. But then at serving, are you getting that feature in the exact same format that your model is used to? uh, and who does the pre-processing of the features when you're serving the model? So in many companies, what happens is, because there are different teams, like modeling is done by a data scientist team. They do the feature engineering, great, they create the model, they hand it off to another team, and that another team is like a production team. So at during production, who is responsible for feature processing?
Yeah.
So, and even if, like, you may say, yeah, the data scientist team is responsible for feature processing and online serving also, great. But then like many times things change, like you found out that the upstream data source is now giving you some data in a different format. Now do you go back to the data scientist team and then say, okay, change this? Like, there's a lot of confusion that happens when those things happen, generally, very normally. So with feature store, you kind of clear out this sense of, okay, who's going to do this part of when upstream data changes, you need to now change your feature processing logic, store it again in store, so that everybody, whoever is using, can grab it from the feature store using APIs.
Also,
So
they will get some notification. Is it like if there's certain change in the features itself? So I'm using X to Xn features, but
mhm.
sometimes some totally different feature is coming in.
So
So should
that
I,
I think depends on like which feature store product you're using. I'm not sure if like there are different.
all of them? Mhm.
Yeah, if all of them have this functionality through APIs, if it is, then great, you have a way to know that, well, your input data is changing, which means pre-processing needs to change, which also may mean that your model may not perform as well as it performed in training, because input data is changing. So I'm not sure if all feature stores provide this functionality, but yeah, it would be a good functionality to have.
Yeah. So my next question will be, how easy is it to plug in different use cases? So think of like us, mostly of consultant companies like where I am working maybe. Yeah, so we change different use case, different domains, different industries, right? So how easy is it to plug in different use cases from the perspective of feature stores and ML pipelines? So do we have to create again a new pipeline, or we can reuse the pipeline and make some small changes?
Yeah, that's a great question. And what I feel is, of course, like for any solution that somebody's creating, they of course have to look at what are the current requirements. Like what is the uh, use case? Like sometimes use cases can be very similar. Like if you're retrofitting a recommendation system engine solution to time series as well, it's going to be very different. But is it a use case that could be used from it, could be reused from an existing solution? So now let's say if you can, if you've identified that two similar use cases are there, and then it depends on for example pipelines. So first thing is, are you using the same pipeline framework? So like if you previously also used Kubeflow pipelines to create pipelines, and now for this use case also you want to use Kubeflow
Yeah.
pipelines, well,
Mm-hmm.
then you know that things will be like this graph, things will be containerized. Then that, okay, the next thing is, are you using the same type of framework? Like for example, in Kubeflow pipelines allow both Kubeflow DSL and TFX DSL. So is that the same? And
Mm-hmm.
let's say, yeah, that's also the same. Well, then then things get a little simpler. Then you have to say, okay, in the new use case, do you have the same set of steps? The same, like you need to pre-process data in this one step, you train, evaluate, and deploy. If the steps are also the same, then your that pipeline is already written for you. The DSL is already something you can reuse.
What is
Then you have,
DLX? Well, I didn't.
oh, DSL, sorry, this is just the domain specific language. It is written in Python. It's just basically Kubeflow's SDK that you use to
Mhm.
compile the pipeline.
Okay.
So your pipeline is just a think of it as just a Python program, and with certain functions that they have defined. What you say is, okay, this is component number one. Let's say data creation. So you say, you write a container there. You say, okay, grab data from BigQuery. Grab data, split it into train and test, and that's it. That's what your first step will do. Create data set. Next step is training. So for training, you say, provide the training data to the training step, and that's your next step for training. And the training is also a module. It's a container. What you say here is, like how you can reuse is, if you've already built a container in a particular ML framework, um, now your new model needs, of course, a new modeling code. So you keep the DSL part the same. You can just swap out the container image, and you can reuse this step.
Okay.
Uh, so let's say both steps, like your previous use case, new use case, both are using TensorFlow. So then your base image also probably is ready. Now you just have to swap out the new modeling code container image, and your step is there. You can reuse it. Um,
So,
does that
uh,
uh, answer
yeah,
for
I
pipeline?
got it. I got it.
Okay.
So, so I think we have. This is one of your maybe your favorite questions that one viewer is asking, our audience is asking, Vishwas Narayan. So, how can we help developers from DevOps background understand the MLOps mechanics? So, if you can explain how is DevOps and MLOps differ and how people can switch, so it may be more helpful to them.
Yeah, absolutely. And this is a great question. Mostly, like, uh, we have seen that DevOps is a like a very efficient practice, and widely, all companies who have to put software systems in production, they need to use DevOps principles. So, DevOps is saying that how do you develop and deploy large scale software systems? So you are mainly concerned with code in a particular framework, and of course multiple teams might be working on it. Some are developing some feature back end, some is doing front end. Great. The two main practices are that define DevOps is this practice of continuous integration, which is saying that okay, multiple teams are there, they can continuously integrate their code into this main application which is deployed. And the next is continuous delivery. So you're saying, could you keep deploying your software in small chunks? With MLOps, what we are saying is MLOps is not just code, it's code plus data. So you need code where you're saying, okay, you're doing whatever framework you're using, you're doing data curation, training, evaluation. You've written some code to do that. Excuse me. And then, of course, for any ML model, you need to make sure what is the data that you're using. So you do a lot of data specific things, like of course ETL type of things. You make sure that the data is clean,
Mm-hmm.
and you find out, okay, you log certain things like what is the data distribution for which you're training, on which you're training this particular model, because later on when you do model monitoring, you need to then see if your data distribution has changed. So machine learning is data plus code. So how do you, so the new thing that gets added, now again, because machine learning is also a software system, like part of it is a software system, you need continuous integration and you need continuous delivery. But continuous integration is no longer just about testing and validating your code components, your ML modeling components, but it's also about, can you validate, test and validate the data that's being fed to these models. And then for continuous delivery, again, it's no longer that one software package that gets deployed, but again also how would you, like, what is the prediction data that's coming in, how do you pre-process those things, and also how do you actually do the prediction, like model prediction service comes into picture.
Mm-hmm.
And then the new thing that comes in case of MLOps is continuous training.
Mm-hmm.
So with DevOps, we would deploy a new application. When there is a the marketing teams come up with, okay, this is the new feature that we need to build, then we go through this entire process of building this new feature, and then we deploy a new application. Or if something breaks in your code which is internal, like something breaks in your internal systems, you deploy a new version. With ML models, what happens is, there is this, like the your model is out there, your model is making predictions for the end users, but then outside circumstances or outside environments change, and so you have like user behavior changes, like of course when, for example, COVID began, user behavior completely change, in terms of, like, if you're thinking about retail, for example,
Yeah.
nobody
Yeah.
went in the store to buy something, nobody bought certain type of things, so user behavior, so that's external data, external factors that change, they
Yeah.
affect your ML models, and hence so you now need to retrain your model. So
Correct.
this continuous training is a practice which is saying you need to monitor your models in production and identify when you want to retrain, and also how you want to retrain. This retraining could be as simple as, I got new data, this current model is like good, you retrain the same model on new data, find out how good it is, deploy. Or it could be that the new data is actually very different, and you need to actually deploy. You can't just use your old models, you need to do some new modeling, like bring in new type of algorithms, restart your entire experimentation process, find out which models which type of models best fit your new data with new characteristics, and then deploy.
Yeah.
So that means MLOps also needs this key functionality of continuous training.
Okay.
Uh,
Very.
does
So
that?
another, yeah,
Yeah.
yeah, very much, very much. But continuous training forms the basis of MLOps. So Vishwas is asking another question like ops fusion and the other model optimization, how it is done in the deployment at scale.
I'm not sure what you mean by ops fusion.
Maybe let's take up model optimization, how it is done at deployment at scale. So maybe is it about, yeah, you want to start off?
So yeah, I can talk about model optimization.
Yeah,
So like mainly like by model optimization, do you mean like what model performs, or you
performance,
hyperparameter tune the model?
hyperparameter. Yeah. So, is there? I also have a question. I wanted to know more about it. Is there any way that we can do hyperparameter tuning more faster in parallel threads, in parallel processes, or is it like estimators? We have n estimators, right? So, how does the entire process work, and how we can make it super fast? Yeah, model optimization.
Okay, sure. So like first to answer like how model optimization is done in deployment at scale, and which also would answer your question about how, like, of course you can multi-thread that this whole thing. So like when these model like when things are at scale, so one, it could be that you don't just have one model that you need to optimize. You have like thousands of models
Exactly.
that you
Exactly.
train every day. Now,
Mhm.
for each of these model, you need to optimize them.
Yeah.
And so, like with the pipelines, so what happens is, like in DevOps, what we used to do is we would check in our like Jenkins repo. We would check in our code artifacts.
Hmm.
uh, Mature users of MLOps, like one thing that they do is they check in entire pipelines into Jenkins. So this pipeline is your, so for each like use case, you have identified through experimentation, you have identified that all these steps need to be done, like 5 steps need to be done before I can deploy it. And given the nature of that use case, you might have to do different types of data processing, different types of hyperparameter tuning. So you club, I mean, you created a pipeline for that particular model, like an end-to-end pipeline.
Hmm.
So when like companies that I've seen that do this at scale, because
Hmm.
they have repeatable pipelines checked into production. When they
Yeah.
need to redeploy a model, they run that pipeline again, and they can completely through scripts, like Python
Automation.
or scripts, they could automate this process so that their teams don't have to individually run notebooks.
Hmm.
It's like in that pipeline you've said, um, this particular for model processing for use case number one, grab this container from the container registry, download it, process it. It's done. Process it, and like train the model, hyperparameter tune it. There you go, it's done.
Do a number of steps. Yeah.
Yeah, yeah.
Yeah.
And then to answer the other thing about, how can you do hyperparameter, like if you want to make this whole thing faster, of course you can design your pipeline such that when you're doing the training, you can make it distributed, or you
Mhm.
could use like accelerators. So not just this whole hyperparameter tuning is not just happening on CPUs, but you can use GPUs to train given your use case, and put multiple parallel steps in your pipeline so that different experiments happen parallelly at the same time.
Right. Got it. Got it. Very, very nice answer. So I think some part of it you have explained, but there is another audience asking you this question. Could you please explain how data drift is analyzed?
Okay, yeah. This concept of like model monitoring. So with respect to like uh, so I was with data drift. Like what happens is there are like multiple things that could happen. So for example, um, your data schema is different. Like so your data schema is queuing, or the actual features that you use. So when you were training your model, your input features had a certain distribution. But then when you are in production and things change. So for example, this example I took of when COVID had just hit, then user behavior had completely changed for retail. And so the input features that were coming in to the models that were being used for prediction, the input features, their distribution had changed. So that is data drift, where your uh, um, like feature data drift is this, that the distribution of your prediction features or online features is different from input features.
Mm-hmm.
Now, how do you measure them? And that's what the question is, like, how do you measure data drift? So, there are several ways. So, for example, there are ways like this Jensen Shannon divergence. It's
Mm-hmm.
one way that you could calculate the distance between two distributions of numerical features. Also, there is like, for if you have categorical variables, then there is this way of like calculating L infinity distance. That's one way you can calculate distance between the two distributions.
Mm-hmm.
So what you do is like this is what model monitoring practices do, that uh, you show where the input data is. They calculate input distribution, and then when you start predicting, the monitoring services are doing this. They're continuously monitoring what type of prediction is coming in, and then they calculate the prediction data uh, feature distribution,
Mm-hmm.
and then they calculate the distance between the two distributions to find out if there is a the this distance between these two is greater than, let's say, you set up some threshold. So that those then can then tell you your data has drifted. So this is one way to do this through
So the next, yeah. So there are a lot of questions coming. If I even couldn't ask my questions. So Benazir,
okay, no problem.
yeah. So what are the use cases when you are talking about self-driving car as the deployment change here? So is it like I don't get the question fully. Means is it like Vishwas? You can ask more things. You can type in. So is it like we have machine learning models for self-driving car deployed in the cloud? That if there is something in the deployment change, what do we do? Does he mean by that, or what do you think? In case Google has a lot of self-driving cars, but if they have some machine learning, I'm sure there are some machine learning models. So if there is deployment change, how they will run the experiments?
uh, okay, well, so I'm not aware much with the self-driving car use case, but if I'm understanding this correctly, are you asking that in a very real-time use case, that
Yeah, yeah, that's what I can understand. Like I am asking, what should be the approach in that use case? Yeah, correct. In a real time
Okay,
use case. So
okay.
how robust is our model, that I know that in a most critical use case that I have trained my model, if I understand it correctly, that the new training is not going to give me some awesome results, not bad results than the previous use case and than the older model. So that's how it's life critical real time systems are, right?
Yeah, yeah, and you don't have time to retrain a new model,
Yeah,
right? It's real
yeah,
time.
yeah.
Yeah. So I don't know if I can completely answer this question, but as far as what I know, is in very like real time use cases. So, for example, in self driving cars, it might be that your entire model retraining part is not in the cloud. It could be that you have it's an edge use case, that your model based on real time use case would be it, not the entire model, but a lightweight version of that model could be retrained on the device, like on mobile, like in your car itself.
Okay. Okay.
So that could be one way, so that you're not going back to the cloud and pulling up the entire pipeline. Of course, you don't have time to do all that. So edge use cases, as far as I know, and I don't know much about this, but edge use cases deploy a lightweight version of your model so that
Yeah.
you could like make predictions in real time. uh, could you do retraining in real time? I'm not much aware with this use case. So
So a kind of could be a kind of federated models, right? Where the device trains some on the incremental part of the data it has collected. Could,
yes, yeah,
right?
yeah, that's right. Yeah, that could be possible, definitely.
Yeah. Okay, so let's ask some. Let's go back to our discussion where we were. Like, what are the basic principles or basic? One viewer has also asked. Vishwas has also asked. Could be the approach. Like, what is the principle making DevOps in ML? Or I would also put it the same questions in a different way. Like, what are the minimal requirements that we plan our use cases, our design process, and architecture in using so many components you talked about, right? The pipelines, Kubeflow. Uh, the feature stores. So when I'm started with one use case, so what is the minimum thing that we should be knowing and to kick off the process, and so that it is useful in the as a DevOps developer or using MLOps?
If I'm understanding this question correctly, are you asking that how could you use existing whatever artifacts you have in, or
Yeah.
processes you have in DevOps, put it into MLOps?
Yeah, yeah, kind of. And also we not only DevOps, like we need for DevOps also we need some components like architectural components, microservices. So what is the minimum thing that we should be aware of if we're shifting it to the pipeline, or day one we should think of the pipeline? How is it? Should from day one should we plan the pipeline, taking all those principles, or we should wait for some time till our process matures and then take it up?
Okay, okay. So like pipelines, like ML pipelines, when you should use them. So one is, of course, like the starting steps are, like mostly people, like when you start, you don't have a pipeline way of doing things. So how you're doing things is manual experimentation. Like you have a lot of code written in different types of Jupyter notebooks by different teams. You run them by hand. You say, okay, first, and of course you people would have scripts to run it. Like they would say, first run this particular notebook from team one for data processing, write this data to GCS,
Mm-hmm.
wherever storage, then run this second notebook, this script which would run the second notebook which would do the modeling from team 2.
Mm-hmm.
So it and this type of approach is works well if you have a small team, and you don't really need to retrain your model a lot.
Mm-hmm.
uh, Great, no problems. But in now in as you progress, um, uh, when you create an like an ML pipeline, this is just like this is an orchestration tool. You're saying that instead of somebody dedicated who would be writing scripts to run notebook 1, notebook 2, notebook 3, I've created this workflow that when I trigger this pipeline, all these steps would be conducted. Now in DevOps, like for example, we use Jenkins as one way to store all our repo. So and of course you have some sort of, like Jenkins also helps with you build, given your whatever you provide your build packages and rules. You say build this package, and then save it in this particular repo here. uh, the same thing with MLOps. So where you have written, you write a pipeline. Like, so one is of course model artifacts. Like you created a model, you have a model file that you save. This is your trained model. Of course,
Correct.
you save that model in Jenkins. You'll build it, you'll save it. With MLOps, the other thing that's coming in is this pipeline that you create. So I talked about the DSL, which is a way to compile the pipeline. So when you
Yeah.
compile the pipeline, you create a, for example, the Kubeflow pipelines create a .json file, and the previous version creates a .yaml file. So that .yaml file is saying that this is the different steps of this pipeline. You also build this and save it in Jenkins, so
Mm-hmm.
that that's another level of thing that comes into MLOps, that you not just save your model artifacts or your code artifacts, but also your pipeline artifacts. Now, you have other things like to do, like for example, TensorFlow also mentions also provides all these different modules. Actually, in the data drift question, I also forgot to mention that TensorFlow has TensorFlow data validation to identify skew and drift between training and test data set, and also TensorFlow model TFMA is there to identify drift. So sorry, I forgot to mention it at that time. But all these different, coming back to the DevOps question, all these different components for data validation also need to be stored, because ML is both code plus data.
Mm-hmm.
Um, so that's how you, so your original ways of like where you store artifacts like GitHub or whatever your cloud repository is, the way you build, the way you like things progress from testing to staging to production, all those infrastructure can be reused, I would say. For the
Okay.
most part they could be reused. It's just what is it that you store in there
So,
that needs
so
to
the
change.
data from the feature stores only needs to be changed based on the use cases, but most of the part of the pipeline can be reused, if I understand it correctly, right?
Yes, with the caveat, of course, that you're using the same type of framework. You have the same set of models. Like for example, let's say in some use case, like this use case is just retail. Before you deploy a model, you don't have to do. All you have to do is you just a simple use case is you find out if the new model that you trained is better than the old model that you trained. If it is, you say go ahead and deploy. But in finance use cases, there is a lot more auditability that comes in. You want to make sure that your data is, let's say you're talking about fraud detection use case. Well then, a lot is at stake, and a lot, your company, by the nature of the use case, you need to comply to a lot of compliance type of regulations, law of the land. So then you build in additional steps in your pipeline to make sure that um, you're doing you're executing all those before you can actually deploy.
Okay.
So
So,
yes, with this caveat, yeah, many things in the pipelines can be reused, and that's why they are, they're modular steps. Like different use cases, different models, they need the same data. You can reuse that step.
okay. So as much as we reuse, it's also a save of time versus time and cost, right?
Yes, yes, and that's a great thing. You save cost, which increases your development velocity, and you have less. It's less error prone if things could be automated and reused.
Yeah, that's should be our objective in as an engineer, right? So Vishwas also is also asking about the model versioning. So how, so you talked about retraining, right? So is it just a change of the version number of the model, or I would say that is it like all the data, which data has been used, what has been the model metrics, everything we have to version?
Yeah, and that's a great point. So now, and that's great. Something that pipelines also helps you. So for example, like when you train a new model, you can give it a new name and a new version. But is that the only thing that you want to do? Like many, for example, in the finance use case that I mentioned, they have a lot of auditability requirements. So they have
Mhm.
to say that, okay, let's say there was a use case where somebody is asking for a loan, and I run their information in a model and I say your loan is denied because so and so reason. So now they can come back, like they could say why is, like, it could be possible that your model is wrong. So if I as a company have to stand behind my model, I need to say, okay, this particular model which made this prediction for this user, how was it trained? What was the actual modeling technique that was used?
Mm-hmm.
Then, if you go even further, what was the data that was used to train this model? How did you split that data? And so if somebody, like when you start the audit chain and you go back in all your steps, it would be a lot easier if you have actually saved those things. Like, you have said, like these, like many financial companies, they train their models every day, like thousands of models every day. So they store metadata related to what data set was used, and they, like, things are time stamped to say, okay, this particular data set which has data from so and so to up till today at this particular timestamp, this data set was used to train this pipeline, I'm sorry, this model. This is how this model was evaluated on this particular metric. And then, this is who, like the actual people, like processes, like this is the person who gave a go ahead that this model could be deployed into production. So all these things, which is called metadata, so not just the data that, the training data or the modeling code, but metadata related to uh, this training data was fed into this model, and then this particular prediction was made using this, needs to be stored. And now more than ever, because well, one, because modeling is, so many companies have models in production, so their revenue is directly impacted by machine learning models. And second, because of, there's a lot of this thing about, you could create a deep learning model, but do you know how it works? Like, can you explain it, and is
Yeah,
it fair?
explainability. Yeah,
So because of both of these reasons, companies are, one under a lot of pressure, and two, they want to do this to make their entire ML process auditable. And in order to make things auditable, you need to, checkpoint everything that you have done. So metadata is, so for example, like Kubeflow pipelines, which is open source, they provide a machine learning metadata functionality. And then, Google's like managed pipelines, which is Vertex pipelines, it has a functionality that metadata is automatically tracked. Like whenever you train a pipeline, your metadata, you don't have to do anything extra, metadata is automatically tracked for you.
that's great. So thanks for the so many insights. And another question I want to take, somebody is asking about AWS, but if you could relate the same concept to Google or to any generic cloud, that would be also great. Could you tell us AWS and ops concepts are applied in each steps to deploy a normal functional oriented, I guess, machine learning that has already been made? So if I understand, the question is something which has already, machine learning is already made. What are the, if you can tell the step names, say maybe training, deploying, some in terms, if there are finite granular steps, if you can highlight.
Okay. So the steps that you need are, so, like you said, the question is, what are the steps that you need in
Mhm.
an ML pipeline to make a
Yeah,
production grade model?
ready model. Yeah.
So, one, I would caveat this with saying that, of course, this is very use case specific. But let's say, if I were to take an example of a simple regression use case
Mhm.
of, you have to, let's say, predict what is the, price of the next Uber ride that you take. So just a simple regression use case. Well, the steps that you need to train this model that you will, want to automate are like things like, of course, uh, the first step would be how to create the training data set, or training and test, like how to get the data set. The next step, things would be like, could you validate this data, that, this is according to a particular schema. For your next step, for the model that you create, you need data in a particular schema. So validate that your data is in the correct schema. um, uh, One step could be to clean this data, like, certain data needs to be, values need to be removed or imputed, or so data cleaning. Next could be training the model. So now, your experiment in experimentation, you trained 5 different models, and you identified that this one model is best for this use case. So in your training pipeline, you can just put that one model. If you want, you can also code all five parallel steps which are doing five different model training. But I'm talking about a training pipeline that you eventually deploy. So you say, this is the training model training that I want to go with. So you say, okay, train this model using this modeling code that's coming from this training data. Next could be model evaluation. So you also created some test data. You provide that as an input here, and you evaluate this model. Next could be, like let's say if you're doing online cloud managed prediction, or of course you could be doing your own hosted prediction server somewhere. So you say, okay, on that particular endpoint, deploy this model, and so you deploy this model. And then the next could be like if you want to continuously monitor your model, then create start the next step could be then the final step could be that create a monitoring service, like start whatever monitoring service you have for this particular model that you recently deployed, and then you end it there. And your model is deployed to that particular endpoint, and the monitoring job is also running. This is one iteration.
Yeah. So the next question is like, just let the audience know, as well as I am also interested. How do we ensure the compatibility of tools and right selection of tools for the cloud services? What database caching will work better in a particular use case? Do we have any benchmarks as a whole, if we look at MLOps pipeline feature stores, or is it just based on experience, intuition, and reading about what people have done? We have to conclude.
Yeah, that's a great question. So, mostly like if you want to make sure like compatibility of tools, and I know it's a big challenge because so many new libraries, new tools, they keep coming
Exactly.
up. So you need to make sure. So all the um, uh, uh, like some new open source library that comes in. So you need to make sure how do or read documentation for those to identify how do those like one component connects to the other component. So whatever interfaces that they have, the like API interfaces that they have, and documentation related to, okay, what is it that you need to provide and in what format. So a lot depends on that. Now that some things like um, whether you want to, like, how do you want to select a tool, like do you want to do open source or cloud, right? That was also
Yeah, 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 yeah,
right.
yeah.
Okay. So uh, it again, it depends a lot on the maturity of your team and your appetite to how much development you want to do. So
Mhm.
if you're a hardcore programmer and you are your team, you enjoy doing this thing, that some new patch is available, you would update, you could rewrite, great. You would have to stay on top of things at that in that point in time. And so that's the fun of using all open source components. So the good thing is things could be free of cost, or like you would spend less cost in actually paying for the service. But then you have to see how much your cost, in terms of man hours or resources, other resources you spend in keeping things up to date. uh, but the second thing is, many industries, and like for example, I work with many customers, and many times even though they are like big customers, but certain team in that organization says, I don't have developers on my team, and I don't, or for example, for pipelines, for example, like you could use Kubeflow pipelines, manage your own Kubernetes infrastructure. Great. If you have the expertise to do it, go ahead. If you don't, and if you then you can say, I want a fully managed, or at least like partially managed. I want a managed solution. So then
Managed.
that's where all the cloud. So at GCP we say, for example, GCP provides a managed service for pipelines. So we say you don't have to worry about the underlying Kubernetes infrastructure. That how will your job run? Does it have enough resources, like enough machine size to run a particular job? You don't have to worry about that. So if you are in your team or your organization is at that place where you want to focus more on the application and not on the underlying infrastructure, then go with managed services. So of course the trade-off is things could be costly, but then cloud services like AWS or GCP, whoever, they take care of all the of course the underlying infrastructure. Things are elastic, then that you only, they have pay for what, I mean, pay for whatever you use type of models. And then whatever new upgrades are coming in, they will do the patching, they'll provide support, and of course you end up paying for that. um,
That's a great way of looking at the solution, as money versus time, effort, everything counts.
yeah.
So we have talked about also about explainability, like, but if you want to highlight any specific tool about explainability, how, as well as it's a big question for big deep learning, because deep learning, as I know, is very difficult to explain to naive or to the businesses. So if you want to highlight any tool, or how should we tackle those problems?
Yeah, yeah, absolutely. Yes, explainability, especially for like deep learning models, or even if it's not a deep learning model, many times it's a different, like a, it could be a really huge XGBoost model. You can't, how do you, like, you, yes, you can visualize
Explain.
that model, but making sense of every prediction is hard. So yes, there are many tools available. So for example, there are so basically you're trying to say, when you create a, like a model. So there are things like, so tools or libraries. So there's something called as Shapley values. So for
Yeah.
example, there's something very simple which is and I think, yeah, Shapley values also does it, which is you're saying, okay, this is the particular prediction. How do I explain it? What features contributed to my model making this prediction? So as part of Shapley values, what it does is it would take one feature out and explain the prediction. It would take another feature out, explain the prediction. So you would know what is the individual features importance. There is a more advanced technique than Shapley values, which is called integrated gradients.
Mm-hmm.
So what integrated gradients is saying is also, again, the same thing. It has a different way of calculating this feature attribution, but they're doing this. They break down the prediction and attribute values to the features of the input, so that you could say, like, if it's an image classification problem, then different pixels will show different, like when you run it through the integrated gradients tool, you can say, okay, which pixel in this image um, contributed to this particular prediction. Or if it's a text use case, then which word. So for example, at Google, there is like, if you deploy in managed prediction at Google, explainability services are available. So if it's a text use case, then you would know what is the weightage of each word for in this particular input, for
That's
the weightage of each word towards this prediction.
got
So
it.
integrated gradients are one way. Shapley values are one. And even in like TensorFlow, for example, like when you're explaining, so you train a model and you find out the test accuracy. But test accuracy gives you the accuracy over your entire test set. You may say great test accuracy, but many a times if you slice your data, so let's say, it's some, again, if I were to take this example of credit monitoring, if you slice the data with respect to, say, gender, or income levels or education, there are different ways you could slice the data, then find out test accuracy. Many times we see that depending on how you've trained the model, that test accuracy is not the same across different slices. So it could
Yeah.
be different for men, different for women. So of course you need to then retrain your model, but how do you identify this? That's also part of explainability. So test accuracy is not always a great measure. So there are tools. So for example, tfma is a tool which is saying that you provide the slices. You say that, okay, the test data, slice it according to gender and give me the test accuracy on each slice. So tfma could do that. And also, like, I know there is a auto slicer tool, which, what you could do is, it would slice the data for you, because you may not know what are the different slices in your data. So
Yeah. So the next question is, what is your view about building a sustainable model and the software lifecycle through MLOps? So maybe sustainable model, and I would add to it in terms of like environment, sustainability, and the deep learning models emitting so much CO2. So what should be our approach in building machine learning, sustainable machine learning models to add to this question?
yeah, this is an up and coming topic about sustainability. So because of course we see so many models which take, use up so much resources just to train. um, so one, I know that, and it's a very new thing. That's so many, I know many cloud services, cloud providers are taking steps. I know, I don't know much, but I know, like, for example, at GCP, what we are doing is, so Google Cloud, I mean Google in general has been, carbon neutral since 2007. And right now there is this new sustainability goal which is saying that by 2030 Google wants to be entirely operate on carbon free energy. So great. Well, how can you as an end user, or I as an end user, make sure that I,
Consume the
whatever
services necessary.
solutions I create are sustainable? So one, so I think of it sometimes in like two ways. One is that, could you make your software practices efficient, so that you could, like, sustainability is what, like, it's reduce, reuse, recycle. So
Right.
could you reuse, your software processes? So for example, ML pipelines lets you do that. Like, you could reuse existing code that you've written for different use cases. Great. The other is, many, so for example, yeah, what I know at Google is, what's recently rolled out is, the different regions where you operate your code in. Different regions are, they will be shown as, they are marked as, how much carbon free energy they use. So there is a small, so, and what is, it is rolled out with the two services right now, with Cloud Run and, I forget the other service, but, and it'll be rolled out soon. There was a blog about it recently. So what you do is, when you are creating an application on the cloud, mostly our concerns are, latency to the end user, or cost, of course, and three, about, things like data residency. Can you put a fourth consideration there? The fourth consideration being, choose the region, like after you've selected these three, like let's say data residency is not an issue, that you, like, let's say somebody being in India could select a region in the US, and process their data there. Like, data residency is not an issue for them. Then make put this as part of your design choice to say, I will select the data region which has the lowest CO2 emission. And so at Google we provide that note. Now, that being said, the other challenge that, and it's an open question even for me, I don't know the answer, but the question is, as and when more companies, like, they will start saying, choose this particular data region, it's carbon efficient. As an end user, do we have ways to double check that, whatever, whenever somebody is saying this data region is carbon free, is it really carbon free? Check for data sources, or whatever studies they have behind the scenes to say, okay, this region is really carbon free, and not, they're not just saying it and making you pay for it, but it really is, um, operates in a sustainable way, so that your applications, when they run on that data center, are also sustainable.
Yeah, that's a great way to just verify rather than looking at what is written somewhere and what is being claimed by any provider and going by that. Thank you
Right,
so much
right.
for
Yeah.
answering this question. So, lastly, I would like to ask the what are the main challenges that you have already advised to many companies, right? How to build pipelines, MLOps, how to use those. You have also worked in different retail use cases. So, what do you feel are the main challenges, and how do you overcome those challenges? As budding data scientists will be looking towards you to get some experience, to hear out some of your experience stories, like some of the challenges that they should be aware of, and they should be always on watch that how they can overcome those.
Sure. So, many of the times, like, problems that I see are, people have some legacy or some a way of doing certain things, and then they want to move to a managed solution that Google Cloud provides. So so one, they could be moving because they don't have expertise. They want to create a new solution, but they don't have expertise in their own team to um, to plumb everything together, and or to use open source. So many of our main, like, in this particular role, many of my challenges come from the part that companies, they want to do some use case, they have some legacy code, so they need some compatibility. They of course want this end-to-end solution, but then they don't want to, because of proprietary reasons, they don't want to share a lot of information about what exactly uh, would their end solution look like, or what might be some challenges. So it's just probably a part of the role that I'm in currently, that through continuous, it's probably like effective communication, or through them I need to slowly understand what gather what are the requirements from the customer about that customized solutions that they want to create using GCP.
Mhm.
Also, of course, every system has its own limitations. So, in creating an end-to-end solution, so I feel that, like, especially now, when then there are so many, because this whole thing is so democratized. Like, anybody with a internet connection could create a model. They could create a library, or they could create a tool, or an easier way to do something. So you need to understand, how do things integrate with each other, and not focus too much on tooling. And so this is another advice that I would want to give people who are, starting out in data science, that this area is in a lot of flux, and a lot of, like, research is happening, and a lot of applied research, like, applied people are applying things in industry. So for example, think of it that, a few years down the line, if you put your head and soul into learning MapReduce, well, for a few years you would have done great, but now, not like MapReduce, because it's harder to use. Nobody uses not nobody, but it's not in as much use, because there are better abstractions available on top.
Okay.
So I would say, and of course, some things like TensorFlow is of course here to stay. So if you so what I mean to say is, if you find some sort of software package or some tool, um, you don't know if in another 2 years time it may be obsolete. So don't focus too much on the tooling. Instead, focus on what is the problem that you want to solve. What is the actual use case? Like, is it, for example, vision related, or text, or like language, or structured data? What is the problem that you want to solve? And then focus on, like, principles. Like, for example, some MLOps principle. And again, this is also something that's continuously being evolved. I don't think there is a any book or something that covers what are MLOps principles that one should, keep in mind all the time. But, certain things are slowly coming up. Things like, making sure that you could have high quality data throughout the entire ML lifecycle. during preparation, during training, during deployment, during monitoring. So making sure that, so that's like one tenet of good MLOps, or good data science in general, that you should have high quality data for whichever step you're doing. And the other thing is, like, also in the same vein as end-to-end solution, I feel that many times when people are starting, like even when I was starting like a few years earlier, I there was a lot of focus on, because it's easier to do, like modeling. So how could you model a particular, uh, like train a model? You need a laptop. I mean, you have a laptop, you could train a model. But so modeling is great, and if that's where your interest is, go in depth there. But you should know how the end-to-end system works. I'm not saying go in depth. You cannot go in depth. There's so many things you cannot go in depth on each and every topic. But you should have a sense of how the end-to-end, like the model that you created or trained, how can
How is
it
it
be used
used
end to end.
end
You
to
should
end?
have a sense of that. And most of my problems have come from that area, that okay, this model is great, works well on training data set, but could actually deploy it, could actually use it in production. So that's another thing I would tell somebody who's starting out in this area. And also one more thing, because probably because modeling is so easy. I mean, I don't mean easy. I mean, it's so easily doable by
Do
anybody who has a computer.
Yeah,
It feels that data scientist is the role, like you should be a data scientist. But especially in this role, after coming to Google, I've seen, and maybe because there's more awareness about these things in general, I've seen that in an AI organization there are many different types of roles. Of course, you could be a data scientist, but if statistics and modeling and math and coding are not your major strengths, you could also there are also other roles, like if you don't enjoy stats and modeling math as much, but you enjoy software engineering, well, ML engineer is a role, or data engineer is a role, or like data analyst, where you're interested in making sense of the data, but you don't want to do data science, like modeling. With data analyst, you could still, for example, with BigQuery, all you need to know is SQL and your business. Like, you could gather insights as long as you know SQL. So I would say, don't get bogged down by data scientist being the only role. There are many other roles, and they are developing more and more.
yeah. That's an absolutely great insight, and I would say also a great advice for young budding data scientists as a future career options. There are so many options available out in the market. Don't be like too much biased that I have to be a
Yeah,
data scientist. That's a lucrative career options, right? There are
yeah,
other options
yeah.
also. Consider that based on your strengths rather than going for the market. What is the market saying?
Right, right.
Absolutely.
Exactly. That's exactly right. Yeah.
Yeah, thank you so much, Benazir. Thanks for agreeing to come, and we have crossed the time limit. And thank you so much for slowly taking the time out and giving each pointer and direction in such a nice, articulating each fact in such a nice manner. So people can reach out to her in LinkedIn if they have any questions. I'm sure she would be happy to answer. And as of now, today, I'm very grateful to you, and we can end today's broadcast here.
Thank
Thank
you.
you.
Thank you, Sharmishta. It was a lot of fun talking to you and, answering all the questions by the users. Thank you so much for having me on your platform. It was an
Yeah,
absolute pleasure.
it's my pleasure, and it will be pleasure to host you again on some other topic.
Definitely. Thank you. Thank you.
Thank you.
Thanks, Sharmishta.